All right, I have a very serious mission for you today. Are you ready? I want you to close your eyes. Seriously, tight shut. Now, imagine you have a cape on your back. It's bright red, it's flapping in the wind, and you are flying way, way up high in the clouds. You are a superhero, and you're hovering silently above a giant, busy city.
That is a pretty cool view. From up there, the world must look, totally different.
It really does. It looks like a giant toy set that someone just spilled on the floor. I see thousands of little gray squares, which I guess are roofs. I see big green blobs. Those are the trees. And I see these long gray snakes winding everywhere. Those have to be the roads.
You're painting quite the picture. You're seeing the shapes of the city. But superhero, here's your problem. Keep looking at those gray squares. Can you point to one and tell me exactly what's happening inside that building right now?
I'm zooming in with my supervision and honestly, no, I can see a roof, but I can't tell if it's a store filled with candy, a school where kids are learning math, or, just a boring office.
And that is the problem. From the sky, a library looks a lot like a grocery store. There's just big boxes with roofs. And believe it or not, this is a huge problem for computers too.
Really? I thought computers were supposed to know everything. Don't they have supervision?
They have cameras, sure, but they struggle with context. And that is the mystery we are cracking today on this deep dive. We're looking at some new research about an invention called SocioReasoner.
SocioReasoner. Wow, that sounds like a super cool detective name.
It kind of is. It's a special kind of computer brain, an artificial intelligence, that's designed to solve that exact mystery. What is that building used for? Just by looking at photos from space.
Okay, but why is that so hard? If a computer sees a picture, can't it just say, that's a building?
It can. Computers are very, very good at seeing physical things. If you show a computer a satellite photo, it's great at saying, that is concrete, or that is water, or that is a tree.
Right, because trees are green and fluffy, and water is blue. That's easy stuff. Even I can do that without supervision.
Exactly. But this new AI, it wants to see social things. It doesn't just want to know what the building is made of. It wants to know where the fun is. It wants to find the places where people meet and play and learn, like parks and schools.
So it's the difference between seeing a building and knowing it's a school.
Spot on. Let's break that down a bit. Think about a university, like a big college campus. From the sky, physically, what does it look like?
Just a bunch of brick buildings, maybe some sidewalks. I mean, it probably looks exactly like a factory or something.
Correct. Physically, they're almost identical. But socially, they're total opposites. One is for making things, the other is for reading books. Or think about a zoo.
Oh, a zoo is a good one. Physically, a zoo is just like some trees, some fences, and some dirt paths.
But socially?
Socially, it's a home for lions and bears.
And that's where it gets really tricky. These social places have what the researchers call invisible boundaries.
Invisible boundaries. That sounds like a force field.
In a way, it is. Think about a park. If I asked a normal computer to find the park, it might just color in the green grass. But is the park only the grass?
No way. The park is also the playground with the slide and the benches and the path where I ride my scooter and the little shop that sells ice cream.
Right. If the computer just colors the grass, it misses the playground. And as we all know, the playground is the most important part.
Obviously. If the computer misses the slide, it failed the mission.
And according to these research papers, this is a massive challenge. There are over 90 different kinds of these social places. They call them socio-classes. And there are over 5,000 specific names the computer is trying to learn.
5,000? So it's trying to find the soccer field or the art museum or the hospital.
Yep. All hidden inside those photos. And remember, it has to tell the difference between a candy store and a dentist office just by looking at the roof.
That seems impossible. If they both have gray roofs, how does the computer figure it out? Does it just, guess?
It doesn't guess.
It cheats. It cheats. Okay, I like where this is going.
Well, sort of. It uses a secret weapon. Something you've probably seen on your parents' phone when you're in the car.
A game.
A map. A digital map.
Oh, like the one with the blue line that tells us where to turn?
That's the one. The scientists made something called the SocioSeg dataset. Basically, they didn't just give the computer the photograph from space. They also give it a drawing, a map that matches the photo perfectly.
I see where this is going. It's like having a treasure map and a photograph of the island at the same time.
That's a great way to put it. The photograph shows you what the world looks like, the trees and roofs. But the treasure map has words on it.
The labels.
Exactly. The digital map has labels. It might have a little icon of a graduation cap for a school or a shopping bag for a store.
So the computer looks at the photo and sees a gray square. It's confused, but then it peeks at the map and sees a label that says school.
And it goes, that gray square is a place for learning. It's connecting the dots between the real world, the photo, and the information world, the map.
Okay, that makes sense. But knowing that's a school is one thing. Drawing a line around it is another. I mean, schools are weird shapes. They have playgrounds and parking lots. Does the computer just take a big crayon and circle the whole thing?
It tries to be much more careful than that. This is where the reasoner part of SocioReasoner comes in. The AI actually thinks a lot like a human artist. It breaks the job into steps.
I like steps. Makes big jobs feel smaller. What's step one?
Step one is called localization. So you shout at the computer, find the school. And the computer looks at the map and the photo, finds the general area, and just draws a big box around it.
Just a box, like a square.
It's just a big, clumsy square. It's a rough guess. It's like when you start a drawing and you just sketch a light circle for where the head is going to go. You're just saying, the school is somewhere inside this box.
Okay, so we have a box. But if the school is shaped like an L, a box is totally wrong. It's going to include the street or the house next door.
You've got it. And that leads to the most amazing part of this AI. Step 2, reflection. The computer has a wait a minute moment.
Oh, wait a minute moment. Machines don't usually do that. They just do what they're told.
This one is designed to stop. It looks at the box it just drew, it renders or draws that box in its mind and asks, does this look right? Does this box actually fit?
That is very human. I do that when I'm coloring. I look at it and go, oops, I went outside the lines.
And that leads to step 3, refinement. The computer realizes the box is too simple, so it puts away the big crayon and picks up, like, a super fine tip marker. It starts using points.
Points, like polka dots.
Exactly like that. Imagine it's playing a game of hot or cold. The computer starts poking around inside that big box with little dots. It puts a green dot on a tiny spot and asks, is this the school?
And since it has the map and the photo, it can check.
Right. It puts a dot on the playground, and the system says, yes, keep that. It puts a dot on the street next door, and the system says, nope, throw that one away.
I get it. So it's testing thousands of little spots to see which ones belong to the school club and which ones don't.
That is the magic. It's so much smarter than trying to trace every little corner. It uses the points to figure out exactly where the school ends and the street begins.
That is so cool. It's like watching a robot learn how to color inside the lines perfectly. But how does the robot get better? Does it know if it made a mistake?
It does. It learns through something called reinforcement learning. It is very, very similar to how you might train a puppy to do a trick.
A computer puppy. I like that. Okay, how do you train a computer puppy?
Well, if you teach a puppy to sit, and it sits, what do?
I give it a treat. And a pat on the head, I let it know I did a good job.
Right. You give it a reward. It's the same with the computer. If it draws the shape of the zoo correctly, the scientists give it a reward, which is a high score. It wants the high score.
And if it draws a messy shape?
Oh.
Or if it circles the wrong building?
No high score. The game says, try again. So the computer tries harder and harder to figure out the rules to get those points.
What does it have to do to get the high score?
The scientists have a really strict grading system. It gets points for 3 things. First, did it find the object? If we asked for a zoo, did it actually find the zoo?
Okay, that makes sense.
Second, is the shape accurate? You know, did you draw neatly around the edges, or did you scribble all over the place?
Got it. Stay inside the lines.
And third, and this is a bit technical, it has to follow the rules of its own computer language. This is called the syntax reward.
So it has to find the right thing, draw it neatly, and speak clearly. That is a well-behaved puppy.
And it really works. The source material gives a great example of the Jinan Zoo.
Oh, tell me about the Jinan Zoo. That sounds like a tough test.
It was. The computer looked at the satellite photo. It saw trees, paths, animal homes, and even a big lake. A normal computer would be totally confused by the lake. It would think, that's water, not a zoo.
Right, because usually water is just water. It doesn't know the water is for the hippos.
Exactly. But the SocioReasoner had the map. It used its reasoning skills, that boxing point checking process, and it carefully drew a line around the entire zoo.
It included the lake.
It did. It included the lake, the paths, everything. Because the social meaning of that place was zoo, it understood the lake was part of the fun.
That is so smart. It's thinking like a person, not just a camera.
It totally beat the older computer models. The older ones would just get confused by everything except the ticket booth.
Okay, but I have a challenge for this robot brain. It sounds like it's really good at finding stuff in one city. But what if we took it on vacation?
A vacation.
Yeah, if I took this AI to a city it has never ever seen before, would it get lost? Or could it still find the playground?
That is the ultimate test for any AI. Scientists call it generalization. Can you use what you learned at home when you go to a new place?
So did they send the computer on a trip?
They did, a digital world tour. They tested this robot brain in cities with totally different styles. Tokyo, New York, London, Nairobi, and Sao Paulo.
Whoa, those are really different places. A school in Tokyo probably doesn't look like a school in Nairobi.
Not at all. Think about Tokyo, super crowded, tons of tall buildings. Then think about Nairobi, which might have more open spaces and different kinds of buildings. Usually this change confuses computers. If a computer learns schools have red brick roofs, and then it goes to a city where schools have flat gray roofs, it panics.
But SocioReasoner has the secret weapon, the map.
Yes. Even though the buildings look different in the photos, a map looks pretty similar everywhere. A blue line is usually a river, whether you're in London or Brazil. A green square is usually a park.
So because it learned to read the map instead of just staring at the colors of the roof, it doesn't get tricked.
That is the key. It was able to find the schools and parks in all those new cities. It did way better than the other famous AI models because it was thinking about the map, not just matching colors.
That's super smart. It's like if you learn to read a map here, you could probably read a map anywhere. The symbols are the same.
It proves that the AI isn't just memorizing, it's actually understanding the logic of a city.
Okay, let's zoom out again. We're back in our superhero capes, hovering above the city. We know there's this smart computer brain down there drawing perfect circles around parks and zoos, but why does this matter? Why should we care if a robot can find a playground?
It matters a lot for how we build our future cities. Think about the people who plan where new things go. The city planners.
The people who decide where the new playground goes.
Yes. There's a very cool idea in the research called the 15-minute city.
A 15-minute city? What's that?
It's an idea that everything you need, your school, the park, the grocery store, should be just a short 15-minute walk from your house.
That sounds amazing. No long car rides. I can just walk to the park.
That's the dream. But to build a city like that, planners need to know exactly where everything is right now. They need a perfect map that says, hey, this neighborhood has 0 parks, or this area needs a grocery store.
I see. And since it would take forever for a person to look at every single building, we need the AI to do it.
Exactly. The SocioReasoner can scan the whole city from space and tell the planners, here are the gaps. Build a playground here. It helps them make sure every kid lives close to the fun stuff.
That is a really good reason. Also, does this help the maps on my parents' phones? Because sometimes that map tells us to turn left into a lake.
It definitely helps there. Those maps need accurate data. If the AI knows exactly where the shopping mall starts and ends, it can guide your car to the right entrance.
Or not into the lake.
Or not into the lake. That's always a plus.
So this isn't just about a computer coloring nice pictures. It's about understanding our world so we can make it better.
That's the beauty of it. It's making the map smarter.
Well, we are just about out of time for this deep dive, but before we go, I have one final thought for you to chew on.
Let's hear it.
Next time you're looking at a map on a screen, remember there might be a smart AI behind it, carefully coloring inside the lines. But here's my big question. If this computer is so good at finding the playgrounds that already exist, do you think one day it could look at a boring, empty lot and invent the perfect playground design for it?
That's a fascinating question. If it knows what makes a park, the trees, the paths, the slides, maybe it could design the ultimate one, a playground designed by a super intelligent robot.
I'd play on that. Something to think about while you fly around in your superhero cape today. Thanks for listening to our deep dive.
Keep looking for those invisible boundaries.
Catch you next time.